So we will start with chapter 2. In our class, we have chapter 2, chapter 3, chapter 10, and chapter 11. So we have 3 chapters. So chapter 2, we all mention, or we will begin with a set theory. And like I mentioned on Tuesday, a lot of this material is a little bit different from your regular math class. It's somewhat critical thinking and outside of the box math. So let's begin with the definition. So we have a set theorem, which is our chapter 2. So what is set theory? What is a set? So in short, a set is basically a collection of some object. Whatever you try to collect, you just put them together. And we call it a set, which is, if you want to collect the grade on the first test, well, just put all the A, all the B, all the C together. That will be the grade of the first test. Or if you want to collect the name of the student in my class, I can put all of your name together, and that will be a set, right? So a set is a contain or a collection of some item that you want to collect. And inside a set, we call each of the item is an element or a member. So if I say, a set of the student in Math 120 section V10, then each one of you will be an element or will be a member of that set. So one thing in terms of a set is very picky. Alex is also very picky, because if it's not in a certain syntax, if it's not in a certain way, they will tell you it's wrong. So how can it be a set? So one thing is we have a roster method. So a roster method is basically you list all of your item inside a bracket or a brace, and then you separate each of your element by a comma. Okay, so there are 3 items that you will encounter in chapter 2, which is the 3 items, which is for now, the 3 items is this 3 item here, which is you have 1, a roster method, and which is a list of items that you collect. 2, you have to describe your set. What is your set contain? What is the item? Which is you just write your word in sentence and you describe what kind of set you have. And the other one, or the last one, which is this is probably the most confusing one, is the set builder notation. So the set builder notation, which is basically they took the 2 items that you have. This is why I tell my students is they took the description of the set. They took the description and they put inside a roster method. Okay, so here comes the notation or the example of a roster method, which is again a roster method, which is again D is equal to dragon, dog, donkey, deer, right? So if you look at this thing here, I forgot to mention, you can name your set. To name your set, you can just use any capital letter. Your capital letter is just basically the reason why you want to name your set is as long as you in that problem, instead of list the set all the time, we just say set D, right? For instance, let's say this example here, set D is dragon, dog, donkey, deer, right? Instead of every time I list dragon, dog, donkey, deer, I just say, well, my set D. And then you say, okay, set D, that's the item is dragon, dog, donkey, deer. Right. So again, looking at this thing here, basically, as you can see, this is your roster method right here, which is the roster method is basically you just list your item out, right? You list your item out, and whatever you list, you have to separate them by a comma. Without a comma, if you don't have a comma, you have only 1 element. Okay, in order to tell me or tell the program how many elements you have to put a comma, separate by a comma. The other thing is you need to have a brace, which is again I call a bracket, which is without this bracket is not a set. So make sure you have to have a bracket in order to be a set. Now, as you can see, the descriptive or the description is easy. It's basically is kind of, I think on Alex they have a choice. You just click and choose the the description that you think is fit, right? So again, the description is basically set D is a set containing an animal start with letter D, right? Not all of them, right? There are some other animal, but again, look at this thing here. You can make whatever description that relate to the set you have, right? So again, it's vary, and that's why I think Alex, they have like a choice. You choose which one that fit closely to your item. So here come the set builder notation. So the set builder notation, ladies and gentlemen, same thing go. You still have a set, right? You still have a set name, which is set D. But now you need to have this brace or this bracket. And inside this set, one thing I want to point out that this is the dummy variable. This is the dummy variable. This variable can be any letter I want it to be. I can let it X, I can let it be Y, I can let it be whatever letter I want it to be. So this is all they tell you is inside this set D, we have D, which is lowercase, such that what are we looking for? The D that we're looking for, such that D is an animal name start with a letter D, right? So looking at this thing here, like I mentioned, all they do is they take the description and put it inside the brace, which is inside the bracket that you have inside the roster. So in the sense, like I mentioned, the set builder notation is just the combination of the description with the roster method. But again, you need this vertical line. The vertical line just say that I'm looking for some element. What is this element we're looking for? Well, the element that we're looking for is the animal name that starts with the letter D. Okay, so again, that's the idea of a set builder notation is we give you some variable, and the variable that we're looking for is the description that we're looking for. Okay, so one thing, if you did the homework, or if you not the homework, if you start with the pie, they probably ask you to maneuver between these three items. They probably give you some roster and they ask you to give the description, or they give you the description and they ask you to list them out in a roster method. Or vice versa, they give you the set builder and they ask you to give the list of the item out, right? So again, basically for the first part is probably they ask you that, which is how can you maneuver between the three, right? If they give the description, can you list out the element in a roster method? Or if they give you the set builder notation, can you put in a roster method? Or if they give you the roster method, can you describe what the set represent? Okay, so again, and one thing in chapter 2, that's the first item in chapter 2 is that's what we do is we try to see the definition and we try to maneuver around, right? We try to see if we have this, can we change to the other one and vice versa, okay? So more notation, which is again, let's take a look at this item here. So for us in chapter 2, the only number that we deal with is a natural number. And a natural number is basically is 1, 2, 3, 4, 5, 6 all the way to positive infinity. Meaning we don't consider any negative number, we don't consider any decimal or any fraction. For us, we only deal with a natural number, which is now. One thing is, earlier I told you guys that you can choose any letter to represent your set, but now the letter N is off limit. You cannot choose the letter N or E or O. The reason why is now every time you see the letter N, you have to know that the letter N represents a natural number. So what's the natural number? The natural number is basically tell you is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to the humongous infinity. Okay. And again, the three elliptic is to basically tell you that it's continuously and does not end, right? And the next thing is the E is just basically tell you that now whenever you see an E is represent an even natural number, which is again 2, 4, 6, 8, 10, 12. Even, which is again anything can divide by 2 is an even number, right? So again, all the way up to infinity, and vice versa. The letter O is off limit. You cannot use the letter O because the letter O represents the odd natural number. The other thing I want to point out, ladies and gentlemen, if you use the 3 dot, I think Alex specified how many element they wanted before you use the 3 dot. But if you give me the 3 dot, make sure you give me some pattern, like at least 3 or 4 number, so that I know what the pattern and what's the sequence is. So sometimes you have 1, 5, 1, 5, 10, 15, meaning every multiple of 5, right? Don't just put 1 comma dot 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 dot, because I don't know what after 1, right? If you put 1, 5, 10 comma dot dot dot, then I know, okay, so it's 1, 5, 10, right? 1, 5, 10, 15, 20, and so on. If you just give me 1 comma dot dot dot, I'm like, wait, is it 2 after or 4, or so give me some pattern. Okay, so those 3, later on you will see that the U is also off limit. So again, you can choose any letter you want except the N, which is natural number, the E, which is even natural number, the O is odd natural number, and later on you will see that the U is the universal set, which is off limit. So any other letter except those 4, right? You can use the S, you can use the T, you can do A, B, C, whatever except those 4. The next definition we have is a set, which is an empty set. An empty set, just like its name, the empty set is just like the name, it's just a set that contains nothing at all. Meaning it's impossible for you to find an element that fit the description. Okay, so whatever the description is, if you cannot find an element that fit that description, then we say that is an empty set, right? Meaning if they ask you, find the triangle that have 4 shaded, right? 4 angle, right? Well, the triangle is, the definition of triangle is 3, right? Tri, right? So if you have 4 sides, which is a square, right? So again, it's impossible for you to find a triangle that have 4 sides, right? So in a sense, that's the idea. And the notation for the empty set is basically, you can give me, please, ladies and gentlemen, you can either give me the braces or the bracket with nothing in it, or the 0 with the line through it. It's either or. Do not combine the 2 together. As you will see later, we do not combine the 2 together. It's either an empty set, which is a bracket with nothing, or a 0 with the line through it. Okay, so that is the empty set, which is just like the name. The empty set is just a set, empty, nothing in it. The next definition we have is a cardinal number or cardinality. Cardinal number is basically, in short word, is basically ask you how many elements or how many members do you have in a set. Okay, so as you can see, we don't know this one here because it's keep on going. As you will see later, if your set is continuously going like this, we don't have a cardinal number because we don't know the endpoint. If there's no dot dot dot, you can see right here we have 4 elements. The cardinal number is 4, right? So again, this is your notation, and this is the hardest part. A lot of students dislike this class. The reason they dislike this class is they have so many notation, right? So your goal is you have to pretty much remember which notation mean which, right? So the definition is easy. Empty set, a set that have nothing, which is empty, right? But the idea is, if they, instead of they say empty set, they give you this symbolic, they give you this symbol, you have to know that this symbol represent the empty set. Or vice versa, cardinal number, you say, okay, cardinal number is easy. Cardinal number, how many elements is in that set? But instead of say cardinal number, they say N of A. Basically, it's the same thing. N of A meaning N of A, which is basically tell you I have a set called A, and inside that set called A, how many element is in that set. Okay, so that is your, that's your objective. That's your goal for this class, is how to distinguish the symbolic that relate to the definition. If you can do that, ladies and gentlemen, I can tell you, if you can do that, 95% of the class is done. If you can recognize the symbolic versus the definition, this class will be very easy. The hardest part is, on the test or on the quiz, they throw all of this symbol at you. Well, we don't have a quiz. So on your homework, on your learning pad, and on your test, they throw all this symbol at you, and you say, wait a minute, which symbol is which? And that's where the confusion part. And you will see later on some symbol look very identical. Okay, and again, right now, make a note, make a flashcard, make somehow knowing that this symbol meaning this, and when it's mean this is what they ask me. So next time they won't say natural number, they just say n. Then you say, okay, capital N, we know that is a natural number. Okay, so let's finish this slide, which is the next notation or symbolic we have is the backward E, or this item here. Is basically tell you the element. Basically ask you, is a given element inside a set, right? Is this element on the left? Later on, the next slide, you will see the example. But the question is basically ask you, is the element on the left side belong or exist in the set I call, whatever the set I call, right? So basically the question, whenever you see this symbolic, is basically tell you, I have this element and is existed in this set. Is that true or false? Okay, so basically, if I write your name and I put this symbol and I say section Math 120, section V10, meaning you, whoever, whatever name is, belong in this class, section Math 120, section V10, right? So again, one thing in this class is we, instead of write it all out, we just use a symbol to represent it. And instead of write the English where all the grammar you have to put in, we convert to symbolic so that we don't have to write a lot of wording, right? And that's the hardest part is remember the symbol. And again, in math, just like anything, if you put the line through it, if the equal sign and you put the line through it, we say it's not equal. Same thing go if we have this backward E and we put the line through it, we say that this is not belong or does not belong in a set, right? So if we put the line through it like this way, we just say that again, I have this element that does not belong in a given set, or it does not exist, right? The existence. Okay. So again, question. First of all, question so far in the sense of the definition and the notation. So
could I ask a question?
Yes.
Yeah, for cardinal numbers, so that could be that it could just say n of any letter, right? We were supposed to read that as the cardinal number. Okay, cool.
So it can be n open parenthesis p if they have a set called p.
Okay.
And last time, remember my set was D, right? Last time I said with D here. So I can say n open parenthesis, a smaller case n open parenthesis D, right? So if, let's take a look at this thing here. So I can say this on your n open parenthesis D. And basically, they ask you, looking at this thing here, if they just ask you this question like this, they say n open D close equal to, meaning again, this set D, how many elements in there, which is you just say 4, right? So again, whatever the set is, this thing it cannot be E. Remember, the E is the even number, and the even number is infinitively many, right? It cannot be E. So whatever the set is can be, n of F, but they have to give you the set F first, okay? So yes, it can be any letter. It doesn't have to be just A. But we read, if it's n of D, I mean n open parenthesis D, we say n of D. If it's G, then we say n of G. So basically that's the concept, okay? So here come, like I say, I want to throw the definition to you first, and then, so that you have all the definition, and then we will attack the problem later. So the next two concept, or this is the confusing two concept, a lot of students have, is the equal set. How can two sets, set A and set B, can be equal? Well, in order to be equal, they have to have exactly the same element, okay? In order to be equal, they have to have exactly the same element. So as long as they have the same element, we say that they are equal. How can two sets be equivalent? As long as they have the same amount. Ladies and gentlemen, to be equivalent, we just need to have the same amount of element, okay? As long as we have the same cardinal number, which is the cardinal number, meaning again, the amount of element in the set. As long as they have the same cardinal number, we call it the two set are equivalent, okay? So equivalent, as long as they have the same amount, they are equivalent. Equal, they need to have the same exact element, okay? One example I tell my student, if we were to be on campus, I can say, let's say my section, Math 120 V10. I have 30 students. The other Math 120 section V22, they have 30 students. Well, the two sections, they are equivalent, right? Because we have the same amount of students. But the two sections are not equal because they have two different students, two different set of students, meaning two different group of students, right? They are not the same exact student, so they are not equal. They can only be equivalent because they have the same amount of students, okay? So equal is very restrict. In order to be equal, they have to be exactly the same. So one thing is, I did not mention this. I did not mention this earlier, but ladies and gentlemen, the element inside your set, the order of the element does not matter, okay? Doesn't matter if the A comes first before a C, before a T, as long as they in here, they are equally the same. So again, doesn't matter the order, as long as you in here, you an A is an A C is a C, a T is a T. So as you can see, looking at this thing here, is set A and set B. Is this two set equivalent, equal, or neither? And hopefully you can see that they are equivalent. Why? Because I have an A over here, right? I have an A over here, is the same as the A over here. I have a C over here, is the same as the C over here, and I have a T over here, is the same as the T over here. Reminder, the order does not matter. So only
they can be equal too, though, right?
They are equal. They can be equivalent, yes.
They can be both, equal and equivalent.
Yes.
Okay.
So one thing is, and that's what the next thing I will tell you is, if the two sets are equal, then they will be automatically equivalent, right? If a two set are equal, they got to be, have to be, must be equivalent. Why? Because in order to be equal, they have to have exactly the same set. And if they have exactly the same set, they got to be the same number, right? So if they are equal, they are imply equivalent, meaning they are both. But if they are equivalent, they might not be equal, right? If they are equivalent, they are not equal. Looking at this thing here, as you can see, C and D, they are equivalent, but they are not equal, right? Why? Because one of them, if you look at the number 5 and 4, well, right? If you can see over here, we have the O and the U and the R. Over here, we have I and V and E, which is, again, the only thing they have in common is the F. right? Which is, again, as you can see, C and D, they are equivalent, but not equal. So equivalent might be equal, might not be equal, doesn't, right? This thing here, they are equivalent and they also equal, right? Right here for A, they are equivalent and equal, but for B, they can only be equivalent by itself. They are not equal, because in order to be equal, they need to have exactly the same element, okay? So again, the amount is equivalent, the exactly same element is equal. And again, for C, as I mentioned, I have to skip E because, again, the word E is the even number, right? So again, F is 1, 2, 5, 1, 2, 3, 4, 5, and G is 3, 4, 5, 7. As you can see, these two items, they are neither equivalent, non-equal, right? Why they are neither? Because, again, clearly they don't have a same amount. One of them have 5 items, the other one have 3 items. And again, if they are not equivalent, again, they don't have the same element, right? One of them have 1 and 2, the other one have number 7, so they are not equal. So again, question here with equivalent versus equal. Now, let's take a look at, so let's throw all this at you guys, right? So after all the definition come in, let's say that I give you this thing here. So I give you this item. I give you set I call A, which is contain 2, 4, 6, 8, 10, which is an even number, right? I have set B, which is contain the first 5 letter, the 5 alphabet. And I have a set C, which is contain this item. So everybody see that this will be given to you. In this case, I give you this. This can be whatever I want it to be. In this case, I have a number, I have letter, I have both number and letter, right? So looking at this thing here, this is what they ask you is determine if this is true. So let's take a look at this symbolic here. What is this symbolic, right? So again, like I mentioned to you guys, this is where the tedious, the aggravation, the frustration come in, right? We give you the definition, is all in word, and now the question, they give you this symbolic. They give you this symbol. You're like, wait a minute here. What is this symbol mean, right? What are they ask me? So that's the challenge for you is, what is this symbolic mean? So if you read it, an element, right? If you read this is basically ask you the letter F, an element F. Is this letter F exist inside the set I call B? So basically, is one of this element, is there an F in here?
No.
Everybody see that? Is an element F belong inside the set that I call B? So you see that the set B is A, B, C, D, E. So the set only have 5 letters, and none of that letter is the letter F. So as you can see that this is a false statement, right? Because I don't have a letter F. There's a letter F in C, right? If this letter to be a capital C, then yes, it will be a true. But because I don't have a letter F in B, that's why it's false. Everybody see the idea of this thing here? So again, is an element I call F belong or inside a set I call B? That's how you were to read that item. Okay, and again, same idea. N of A is equal to 4. Is that a true statement or a false statement? So what is
False.
N of A? False, right? Why? What is the N of A? Reminder, N of A is how many elements inside the set we call A. So inside this set I call A, how many elements are there? Which is, everybody see, we have 5 elements, right? It's not the number 4. We're not looking for number 4. We're looking for how many elements, which is in this case, there are 5 elements. And because there's 5 elements, and this thing here just tell me 4, which is, that's why it's a false statement, right? And again, same idea, same item, which is again, a letter C, not the capital, And that's where the tricky part come in is Alex will throw this at you, right? Alex will give you this, which is not, you have to know the difference between a lowercase versus the uppercase. The uppercase is all the set, the name of the set. So they tell you, is this a true statement? A letter C does not belong in a set I call A, right? So as you can see, looking at this thing here, this is a true statement, right? A true statement, because letter C is nowhere to be found here, so that's true. C does not exist here, right? So again, that's why it's true. C is in B and C is in C, but C is not in A, which is that is a true statement. Okay, so that's the idea of this thing here, which is again, set A is equivalent to set C. Is that a true statement? Set A is equivalent to set C. Again,
Yes.
remind, what's that?
Yes.
Is it false?
Because it's the same, 1, 2. It's the same amount. Wait, no. C is 6 and A
False.
is 5.
False. Right?
Right?
False, right? Because in A, we have 5 elements, right? We have 5 elements, and in C, they have 6, right? B and A, and that's where the item is. A and B, they are equivalent, right? A and B are equivalent, but A and C are not equivalent, right? So again, that's the idea, and that's where the frustration come in, right? And again, as you can see, you just count the number C, which is this thing here is a true statement because N of C, they are
I have
6.
a question.
Question.
So on D, where it says set A is equivalent to set C, even if it has 2 of the same numbers, it's not equivalent?
If they have the 2 of the same number, what do you mean 2 of the same number?
They
You
both
get
have
the
2 and
2, 4 and the 2, 4 here?
Yes.
No, it's not equivalent. Remember, the definition of equivalent is the 2 sets have to have the same amount. Okay, the 2
Okay.
sets have to have the same amount. So one thing that I also did not mention to you guys is I forgot to mention, if they give you something like this, excuse me, if they give you something like this, let me ask you guys this question here. Let's say if I give you this question, and then the question is this. All right. So let's say if I give you this question, I say I have a set I call H, and the set I call H, I have 1, 3, 5, 7, 1, 2, 1, 5, and the question they ask you is N sub H. So N sub H, if you remember, N sub H, meaning they ask you how many elements inside the set we call H. Agree? So when we went over the cardinal number, I forgot to emphasize that when you count the element, they have to be distinguished. Meaning, even though you repeat it, you do not count it more than 1. Okay? So even though
So
you
the 1
repeat it,
would be only counted 1.
exactly. The 1 you can only count it 1, and the 5 you can only count it 1 time. No matter how many times you repeat it, as long as they are repeated, you only count as 1 element. Okay, so you don't double count. So as long as they are not distinct, meaning as long as they are not different, then you count only 1 element. So looking at this thing here, in total, you only have 5 elements. Everybody see that?
Yes.
Okay, so make sure, and in terms of that, and this is where the tricky part, or this is where Alex trick you, is they ask you this question, right? Let's say F. If they ask you this thing here, which is set A is equivalent to set H, is that true or false, right? If they ask you this question, is that a true or false statement,
Say A is equivalent.
right?
Yes.
So again, everybody see that this is what they could ask you, right?
But will it be true since they got 5 elements in each set?
Exactly. Exactly. It will be true because again, remember n of A. What is n of A? N of A is equal to 5. Agree? N of A, we have 5 items. And n of H, we have 5 items. The rule for equivalent is just tell you that, I cannot just, the rule for equivalent just tell you is as long as the 2 items, n of A, is equal to n of H. As long as this thing here is equal, then they are equivalent, which is in this case, everybody see that this is a true statement, right? So again, that's what sometimes they will trick you and you say, wait a minute, Mr. Tran, my hindsight, I look at this thing here and I see that there are 8, but again, remember, it's not 8 different elements. You know, they have 8, but it's not distinguishable because the one here, they are repeated. So even if they repeat it, we cannot count it twice. Okay, so make sure when you do your learning path, they will throw this thing at you. Make sure that you recognize that if I repeat it, I do not count extra. We only count at one time. So basically, in theory, right? In theory, this is my set. This is my set H. In theory, this is what I have in my set H because the 1, I do not count it, and the 5, I do not count it. Everybody see that? Everybody see the idea of repeated?
Yes.
Yes.
All right.
Yes.
So let's take a look at, let me say, let's take a look at what we have next. And again, I think, I believe those are the main thing in 2.1. I think the next one I have is 2.2. Again, let's go over to 2.2, which is the first group of material that due, the first group of learning path that is due by September the 3rd, I believe, is 2.1 and 2.2. I mean 2.1, 2.2, 2.3, and 2.4, but the first group is 2.1 and 2.2. So let me cover it so when you do it, you have an idea of the item. So we will go more detail on Tuesday. I go over this so that when you over the weekend, when you do the homework, you have an idea of what to do, or at least some idea of what type of the question will be. So like I mentioned before, you know, chapter 2 is a lot of notation. So 2.2, we deal with a subset. So subset is basically, the definition of subset is basically a portion of a set. Okay, so this is what they tell you is as long as everything in A, is also in B, then we say that A is a subset of B. Meaning as long as B contain whatever A have, then we say that A is a subset of B. So B have to contain, they have to offer whatever A offer. Okay, so again, the notation, like I mentioned to you guys, remember the other notation with the backward E, this one is the underlying C. Okay, so A is a subset of B. We only read from left to right, ladies and gentlemen. This thing here, A C underline, which is A, is a subset of B. That's what we read, right? Set A is a subset of B. And now the other one, to make things a little bit difficult and to make things a little bit challenging, we have a specific name. And this thing here is basically, they tell you this, which is a keyword that a lot of students get confused, is not. Okay, so if set A is a subset of set B, meaning first of all, they have to be subset, and also they are not equal, right? So if set A is smaller than set B, then we say that they are a proper subset, which is a proper subset is basically just a C. Okay, so one way I told my student is just imagine your inequality symbol. If you remember your inequality symbol, which is your inequality symbol was something like this, right? We have a less than or greater than, right? If it's a less than or greater than, then all we have is we can only choose a number bigger than or smaller than that item. Oh, this text cannot give me a less than or equal symbol. No. If we have, remember if there's an underline, if we have something like this, which is less than, I can do this. Give me 1 second. If we have this item here, which is again, remember if we have less than or equal to, meaning we can include the endpoint. If we have greater than or equal to, meaning we can include the endpoint. So the same concept, the same idea is if you have an underline, if you have an underline C, meaning the two sets can be equal to each other, meaning they are subset. They are equal, they can be equal to each other. If you don't have the underline, meaning they can only be proper subset. And when they are proper subset, meaning the two sets cannot be equal to each other. If they are not equal to each other and they are subset, then we call it a proper subset. We just have a specific name for it, okay? So again, the other thing that, that I want to point out that if a set are proper subset, then they will be a subset, meaning they will be both. Just like before, if two sets are equal, they will be equivalent, right? So if a subset is a proper subset, they will be a subset. Some subset cannot be proper, but every proper subset is a subset. Is that making sense? Because in order to be a proper subset, first, you got to be a subset, right? So if you're a subset and then you are not equal, we call you a proper subset. We give you a specific name, we call it proper, okay? So all proper subset is also a subset, okay? It just, the definition, a lot of people, and in this class, we have that indirect relationship. When they are not equal, we tell them that they are proper subset. When they are equal, they are not proper. They can only be subset, okay? And again, I know that this is the first time you saw this kind of math, and we throw in all this definition and all this symbolic to you guys, but over the weekend, sit down and look at the symbolic, try to see what is the symbolic mean, and try to see what are they asking you. If you can figure that out, ladies and gentlemen, this class would be very doable, okay? To add matter words, to add matter words, this is the other thing we have is two facts. This thing will always be true, is every set is a subset of itself, okay? Why every set is a subset of itself? Because again, as you know, if they are a same set, then they are equal, right? If we have a same exact element, they are equal set. And if they are equal set, they will be subset, okay? So every set is a subset of itself, and the empty set is a subset of every set, okay? So an empty set will always be a subset of every single set you have. So those are the two facts. Okay, so again, question with this two item here, which is a empty set is a subset of every single set, and every set is a subset of itself. So we will go into another facts later, but let's take a look at this thing here. Let's see if you understand a subset item. So they throw everything at you right here, ladies and gentlemen. They throw what you learned in chapter 1, in 2.1 with 2.2. So if you read this thing here, the question they ask you is this: I have a set, right? This right here. I have a set, I contain an element 10. That is one set. Is this set a subset of this item here? So you have to say, wait a minute, what is this item mean? Right? What is this item mean? Well, looking at this thing here, reminder that this item is, they call this set is X. What are you looking for, X? What is the description of X? X, such that X is an even number. So do you agree that if you were to type this out, if you were to type this out, you know, do you agree that this is what I have? If I were to list them out, if I were to put in a raster method, do you agree that even natural number, which is the 2, the 4, the 6, the 10, the 8, the 10, the 12, the 14, the 16, so on, all the way to positive infinity, right? So that's the challenge. Like I mentioned to you guys, in this thing here, they don't ask you to list them, but they ask you to understand what is this set represent, right? This X, what are you looking for? I'm looking for an X. What is this X that you're looking for? Well, the X that I'm looking for is any even natural number. So as long as it fits this description, it's in this set. So to go back to the question, is this a true statement that a set contain number 10 is in a set of this item, which is, do you agree that this set contain this item?
Yes.
So if they contain, meaning it's a true statement. Okay, and that's how you analyze, or that's how you describe, not describe, but that's how you, your goal for this class is how can you decipher the notation, right? How can you decipher this notation? Because they don't spell it out for you. You know, they give you all this notation and you have to decipher them out.
Now, Mr.
Right?
Trent, before you go to the example B, when we did the 10, the reason why we are saying that that is true is because we had, once we wrote it out, 10 was actually in the bracket.
Yes.
That's the reason why? Okay. So I just wanted to make sure. Okay.
Right. It fit the description, right? 10 is fit the description as even natural number. If this were to be number 11, then it's not fit the even description.
So just because it's an even number, even if 10 wasn't in a bracket, it still fit the description?
No. If it's not in a bracket, if this were to be a question, then again, first of all, this is, I think this is what you asked, right? If the question like this, 10 subset of that, is that what your question is?
Oh, I see what you're saying. That's okay.
Right. Your question is if 10 not in the bracket, right? One thing is, ladies and gentlemen, in order to be a subset, the first item have to be a set. And if 10 is not in a bracket, this is not a set. This is just an element. Oh, no, not really an element. This is just a number 10. It just tell me that I have number 10, okay? So everybody see the difference between this 10 versus this 10 right here. Again, remember, in order to be a subset, the two items have to be a set. So if it's just 10 itself, it just tell me some random number. And this thing here is the number 10. So in order to be a subset, the first item have to be a set. So that's why it has to be in the bracket, which is, again, that's why I told you guys that is picky in the way that in order to be a set, it have to be in a bracket. Okay, so that's why we have a set here. That's why, as you can see, this is a set. And that's the difference between this notation, the underline C, versus the backward E, right? Remember that backward E, not backward E, like a capital E, right? So again, and that's where Alex challenge you. I shouldn't say trick. They want to challenge you, make sure that you understand the full concept of the material, okay? So looking at this thing here, is this a true statement? 12, a subset, a set contain number 12 is a subset of 1, 3, 5, 7.
False.
false, right? If you see the pattern, if you see the sequence, you probably say 1, 3, 5, 7, 9, 11, which is the odd number, right? So looking at this thing here, or every time you jump, you add 2, right? You add 2 to get 3, you add 2 to get 5, you add 2 to get 7, you add 2 to get 9, you add 2 to get 11, you add 2 to get 13, which is 12 is not one of that number. So we know that it's a false statement, okay? And vice versa, for instance, if they ask you this thing here, and again, I know the challenge that you guys run into, and that's why, you know, I know that a lot of you guys, this item will give you a lot of trouble in terms of set builder notation. Again, if you look at this item here, in short, right? In short, basically, this is what they ask you is A, B, C, D, E, ... Z, right?
So it's true.
Everybody see that in short, whatever this word, whatever this description is, they say we're looking for some X such that that X fit this description. What is the description? The description is a letter in our alphabet. I should be specific and say English alphabet. But again, just assume that this is an English alphabet, which is from A all the way to Z. And everybody see the difference between this item that I type right here versus this item up here. This right here, we have an end point, right? We have a stopping point, which is tell you that A, B, C, D, E, F, G, H, I, J, all the way to Z. This thing here doesn't have a stopping point, meaning it's always go to infinity, okay? So again, you will see later that this is a finite. When they have a fixed number, it's a finite set. If they don't have a fixed number, it's an infinite set. Infinitely many items. So infinite set versus finite, okay? But again, go back to this thing here. You can see that this thing here is a proper subset, right? It's true that this is a proper subset, right? A set contain F, G, H, K is a proper subset. Why is a proper subset? Because this set and this set are not equal, okay? And again, because they are not equal, that's why they are proper. Yes, it's also true if they are subset. No, if they put a subset in there, it's also true, okay? So they are both proper subset and subset. And like I mentioned earlier, if you are a proper subset, you will always be a subset, okay? Is this item, if you read this thing here, and again, remember what kind of symbolic is this? This is an empty set. Is an empty set a subset of a set contain all AT?
False.
Why
Why would it? I would say
True.
false.
not
Is
false?
it false since it's an empty set?
True,
Not
because
false.
an empty set is in every set.
Yes. Reminder, an empty set is a subset of every single set, okay? So this is how I explain to my student if you take a look at this thing here. So let's say I have a set. So my set, do you agree that my set is this? Do you agree that my set contains the letter A, the letter R, the letter T? Agree? So that's my set. But looking at this thing here, before I put in the R, the A, the T, what do I begin with? So one thing is an empty set. Think in terms of an empty set like an origin, right? It's the beginning. Without an empty set, you cannot have any other set, right? So think in terms that the empty set is the origin of all set. So in the center of this thing here, before I can have something, I have to start with nothing, right? This is the first set that I have. It's an empty set.
Okay.
Once I have this, which is now I have something in it, which is when I have something in it, an empty set is a subset of a set that have something in it. Is that making sense?
I guess.
So just thinking, so if you look at this thing here, if you, let's go back. I don't have a math symbolic. Let's go to the next one and then I go back to this. But again, looking at this thing here, the fact that I mentioned to you guys is one of the facts that you have not to know is an empty set is a subset of every single set there is. Okay, and let's do the last, I think, not the last one, second to last one, and then I will go back and tell you the other one. Blue, red, yellow is a proper subset of green, brown, gray, blue. So let me ask you guys, is this, now first question first. Now, this is what you want to do first, is this. Is this item right here? Ask yourself this question first. Don't ask yourself what they ask you. Ask yourself, is this item a subset of this item? Is everything in here in here? Is blue in here?
No.
So if you look at this thing here, you can see that blue is here and blue is here. So blue is there, right? And that's it. Do you agree that blue is the only item in this item and is in that item, right?
Yeah.
So the second item does not contain everything in the first item I'm asking for, so they are not subset, right? Because remember, I told you that in order to be a subset, the second item have to contain whatever the first item offer. So you have to ask yourself, is this item right here, is this item contain everything the first item offer? So because they don't contain it, then they are not subset. And if they are not subset, ladies and gentlemen, if they are not subset, they are no way that they are proper subset. First, you got to be a subset. Once you are a subset, now we will give you a specific name, which is if you are proper or not. Okay, so if you are not a subset, there are no way you are a proper subset. Okay. So trick question come in is this, which is, let me go and ask you, is this a true statement or false statement? A set contain an empty set is a subset of an empty set.
False.
Why?
False.
Because you can't put a empty set inside of an empty set.
Well, you could.
Well, you can't write it like that. You have to. It has to be either or.
Right. First of all, that's good. It has to be either or.
Okay.
But the other thing is, a set of contains something. Remember, what is an empty set? An empty set is a set contain nothing, right? If a set contains something, no matter what this thing is, even though I know in reality it's empty, but the first thing is we have some item in it. So to be in short, this thing have something. They have something in it, and if they have something in it, it cannot be a subset of something that doesn't have anything in it.
Okay.
Okay.
So
So
only because it has, Mr. Train, only because it has the brackets and it has something in it, that's why it's false?
yes,
Okay.
yes. And that's what the and that's what we have is the first item. The first item have something in it, and when the first item has something in it, it's not a subset of something not, right? So this is what I want to mention to you guys last time was this, which is, for instance, if you remember or if you take a look at this thing here, the
It's on the second row.
so the idea of, remember the idea of this item here, the idea of a subset is basically they tell you this, right? They tell you is the second item here contain everything the first item offer. So looking at this thing here, looking at this item, if it's a little bit, looking at this item, everybody see that, like I mentioned, first of all, this is one of the fact, right? Every set is a subset of itself. That's a fact. Why? Because everything in here is in here. Meaning, again, even if I put 1, everything in here is in here, which is, again, do you agree that the definition of subset is that everything in the first set is also in the second set, which is, again, that's why they are subset. So that's the first idea, is every set is a subset of itself, right? Now, the second idea, or this is what I mentioned, is every subset, I mean not subset, the empty set is a subset of itself, okay? The reason why F is false, because this thing here is not empty. This thing here has something in it. Even though whatever in it is an empty set, just imagine that this is an empty set. It's not a right symbolic, but imagine that this is an empty set, right? So even though the thing inside is an empty set, but they got something in it, right? And because they have something in it, they are not a subset of an empty set, okay? Just because they include something, right? This thing can be something, doesn't matter, it can be 0. As long as you have something, you are not a subset, because this thing does not include what you offer, okay? You already read from left to right, that's why I mentioned, okay? So looking at this thing here, everybody see that this thing here is false, because the first item have more thing than the second item, okay? Now, to go back to this item here, to go back to this item, which is D, the reason why it's true is because, like I mentioned, before I have the word RAT in it, that looks so negative. Let me change to A. Let me change to some positive, right? If I have ART, right, ART, again, they are equal. Reminder, the order doesn't matter. So looking at this thing here, before I have this thing in it, I got to start with a, right? I have to start with nothing. So that's why an empty set is a subset of every single set there is, okay? So again, those are just the two facts. Those are just the two facts that we have, is every set is a subset of self. The empty set is a subset of everything, okay? So the origin is an empty set, okay? So that's why we have this item is false, because this is not an empty set. If it's reversed, then it's true, okay? Question with this, and again, the ebook is online, right? The ebook is online. You can read the ebook if you need to. Also, when you do your pad, if you stop, you can always click on explain. They can explain it to you. Click on textbook. They show you the information in the textbook, and they have video and those stuff. First of all, question with anything here?
No.
No.